Welcome back, guys. This is page 3 of the Unit 5 test. This page is worth 3 points. This is all review stuff. So you'll see number 11 here is a proof. And a couple of ways that I can go about this proof. There's only one blank here, so it's only worth 1 point. But one of the things that I can do in this proof is I can actually, because it's multiple choice, I can just kind of do trial and error if I want to. Or if I'm really keen on my proving abilities, I can just see what this thing needs to be kind of as the proof goes about. So you can follow along the statements and the reasons. We have ABCD as a parallelogram with diagonal AC is given to us. AB is parallel to CD and AD is parallel to BC. That's the definition of parallelogram. Then I have angle 2 and angle 3 are congruent, 1 and 4 because alternate interior angles are congruent. That's one of them because I have parallel lines I'm allowed to use now. Once I have congruent angles, the measures have to be equal. That's a property. And so the measure of angle 2, then you'll notice that I take the measure of angle 2 is equal to the measure of angle 3. The measure of angle 1 is equal to the measure of angle 4. And I take the measure of angle 1, the measure of angle 4, they're equal. Then I add the measure of angle 2 to them. So that's kind of the step I'm at right there. I'm adding the same thing to both sides. It's like when we have to solve a algebra equation, I say, well, add 2 to both sides. I'm just adding the measure of angle 2. Then what changes from the line that the arrow is pointing at? What changes in the next line down? Well, I can see the left side is still the same. No changes. The right side, the measure of angle 4, is still the same. No changes. So the only change that happened is I've changed the measure of angle 2 to the measure of angle 3. And what allows me to make that change? Well, if I look back at the previous line, I can see that the measure of angle 2 is equal to the measure of angle 3. So I can replace a measure of angle 2 at any time with a measure of angle 3 by substitution. This is substitution. So the answer is B, substitution. Now, let me talk about why the other ones are wrong. Sometimes it helps to see why the other ones are wrong. So if I look at what the statement is, there we go. This statement, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4 plus the measure of angle 3. ASA, if ASA is a reason, the statement has to be some triangle is congruent to another triangle. So I know that one's wrong. Angle addition postulate, that says something to the effect of, let me draw an angle here. The measure of angle 1 plus the measure of angle 2 equals the whole angle. Well, that's not what this is saying. This is saying the measure of angle 1 plus the measure of angle 2 equals 2 other things. So I can kind of throw that one out right away. And alternate interior angles are congruent. There's not even a congruent symbol in there. There are equal signs in there. No congruent symbol in there. So really, I could have gotten to this one by process of elimination pretty easy. All right, numbers 12 and 13, these are a point apiece. Question 12 is 1, question 13 is 1. And these are both SOHCAHTOA problems. So SOHCAHTOA. There we go, SOHCAHTOA. Okay, so question number 12, my angle is 15. Label my hypotenuse, opposite, and adjacent. One of them has nothing, the hypotenuse has nothing, so I'll get rid of it. O and A, this is tan. So the tangent of the angle, tangent of 15, equals the opposite over the adjacent. The opposite is 38 over the adjacent, which is x. When x is on the bottom of the fraction, you can do the switcheroo. So I'll switch x with the tangent of 15. So you'll have to make sure your calculator is in degree mode. Do not be in radians, be in degrees. Do 38 divided by the tangent of 15, and you should get rounded to the nearest tenth, as the problem states. If you look up here, round your final answer to the nearest tenth. So that's 1 decimal point. So 141.8 when it is rounded. Number 13, again, here's my angle. So hypotenuse, opposite, adjacent. This one is empty, it's the hypotenuse again. So O&A, again, it's tangent. Tangent of the angle, y, is equal to opposite 12 over adjacent 18. Well, now I have to get rid of the tan. I can't subtract tan or divide by tan. I have to do tangent -1, called the inverse tangent. So y equals tangent inverse of 12 over 18. So you have to hit the second button on your calculator. So second tan, 12 divided by 18, hit enter, rounded to the nearest tenth. It is 33.7. 33.7. 3 questions, 3 points. That is the end of page 3. The last video coming next.